Okay, so let's get started here, right? So we're talking about, it says how many different combinations of sandwich side and beverages are possible, right? And so this is a straight up, pretty simple, um, fundamental counting principle problem, right? So you know that with the hot dog and chips, you have four options, right? With hot dog and apples, you have four options. With hot dogs and pasta salads, you have four options, right? And so you can kind of go through it that way and see how many you have. And so the easy way to do this is just say, okay, well, you've got one, two, three, four, five here, you've got three here, and you've got four here. So you just go 5 times 3 times 4, right, which is 15 times 4, which is 60 options. And if you don't trust that you did it, then just, go hot dog first, right? So if hot dogs first, well, you know, you can have chips and water. You can have chips and soda, chips and juice, chips and milk. And then you could do apple and then water, apple soda, apple juice, apple milk, and then do pasta salad, pasta, water, pasta soda, pasta juice, pasta milk. And that is just these, right? That's just these. So this gave you 12 options, right? And that was just with hot dog. And you're going to have the same 12 options available if you choose each one of these. So there's four more. So that means there's five sets of 12, which is 60. So with a little common sense, if you forget this fundamental counting principle, or that you have to apply it in this case, then you can kind of reason it out. And that's sort of why one of the things I do like about probability. And probability, like I've said, is kind of complicated for me. Doesn't always make sense, but I think that this is a good way to approach it. Just don't be scared of it. All right. Okay, next one. How many ways, all right, when they're asking you ways, okay, we know we got a permutation or a combination problem, right? So it's going to be one or the other. We're going to either have perm or combination, all right? So it says how many ways are there to choose the winner, first, second, and third runners up in a contest with 10 finalists? Well, the order absolutely is important in this because it's a contest, right? And there's a big difference between getting first place and 10th place, right? So we are going to figure this out. So it says the winner and first, second, and third runners up. So they're asking us to find four places, right? To find how many ways are there to choose four places. All right. So the first one, right? So for the winner, right, there are 10 choices. All right. Now, for the first runner up, all right, I never knew why they did this, by the way. I just think it should be first place, second place, third place, fourth place. But whatever. They don't want to give fourth place. That's like bad. So for the first runner up, there's now 9 choices because you already picked somebody. For the second runner up, aka third place, right? You've used 2, so there's 8 left, and then for your fourth place or third runner up, right? Third runner up. I'm trying to use their language, but I hate that. It's 7, right? And so 10 times 9 times 8 times 7. Order is important. This is a permutation, so there will be no division step at the end. It's just 10 times 9 times 8 times 7. So you just grab a calculator and start multiplying, just wantonly crazy, plugging things in. So 10 times 9 times 8 times 7 gives you 5,040. 5,040 ways. All right. All right. Now, next one. All right. So number 6. Okay, number 6 says how many different 2-topping pizzas can be made if there's 6 options for toppings. All right. So you're choosing 2 toppings, right, out of 6, right? And so here is this a permutation or a combination? Well, is order important? And does it matter if you pick sausage first and pepperoni second, or if you pick pepperoni first and sausage second? No. So this is a combination one. And so we will have a division step on this one. right? So for your first topping, right? So you go first topping, right? For your first topping, you have 6 options. So there's 6. And for your second topping, right, you now are down to 5, because we're assuming they're not allowing double toppings, right? And so that gives you 30, right? But remember, there are 2 different ways to arrange the 2 toppings. So it's divided by 2 times 1, right? Which is just 2, right? So 30 over 2, how many ways are there to arrange 2 items? Well, 2. So 30 divided by 2 is 15. And that is how many different pizzas you can make with 6 options. And it seems like it shouldn't be enough, but it is, because you're going to have overlap on those when you set it up, right? Because like we said, order is not important with this. All right, last one. The community center hosts a talent contest for local musicians. On a given evening, 6 musicians are scheduled. The order in which the musicians perform is randomly selected during the show. What is the probability that the musicians perform in alphabetical order by last name, assuming no 2 musicians have the last name? All right, so basically what all this tells us right here, this probability of musicians perform, right? So what they're saying, I got to make sure that this, yeah. So what they're asking us is what they're telling us is they're telling us, hey, order matters. All right, order matters. So if order matters, that means that this is a permutation. And we like permutations because there's no division. All right, so you got 6 musicians, and the order in which they're performing matters. Okay, because we're trying to do it in alphabetical order. We're trying to see if it will be in alphabetical order. So that means the first one, so the first act, right? The first act, there's 6 choices. Second act, assuming you picked the one that comes first in the alphabet, you now have 5 choices, and then you can go down like this: 4 times 3 times 2 times 1. Just down to 1, right? And so you got 6 times 5 times 4 times 3 times 2 times 1, okay? And then you just basically multiply that out because this is a permutation. So 6 times 5 is 30, times 4 is 120, 120 times 3 is 360, 360 times 2 is 720, and 720 times 1 is 720. So there are 700, and so there's 720 ways, right, in which the order matters, and you want one that is very specific. So you want 1 out of 720. All right, so we got to turn this into a probability. So 1 divided by 720 gives us 0.00139, all right, which is 0.14%. So less than 0.15% chance that you will pick it that way. But like I said, we got to figure out, does order matter, and then go from there. So hope this helps. Have fun with these, and we'll see you.